Hello friends, welcome to the Laptex. My name is Nasser and today we have a case study of HP15 and the part number is LA-C701p. You might have remember I have uploaded same video, same amount of video like it is turning on but low load. And if you have seen that video, you would have seen that there was a 3.3 and 5 volt regulator was faulty in that motherboard. Now let's check condition first. What is the scenario? So let me insert the DC jack. Light is available on the DC jack, okay, and load is normal. It will go high and it will down. It will enter into the suspended state. This is the indication. And now I'm turning on. So let's press on off switch. And you say 0.042 is the load. So how do we check motherboard? Again and again, the same thing we have described many times, that you should begin it from the RTC section. There are the lots of requirement after that. Lots of communication is required. So you need to understand the communication between the CPU and PCH and SIO. Then go a long way. You would be able to rectify the problem. Otherwise, what will happen that you will temper the board, like somebody has already done some work on this place. As you can see, it is quite noticeable on this point. See the solder mark and also the paste. It seems that RTC area has been worked, but we will find out that is it okay or not. We will confirm it now. So where is my cleaning brush? Yes, let's clean this area and see anything is missing from the board. No, everything is all right. So as you can see, everything is quite clear and crystal. It's all right. Definitely the guy who has sent it to me, he also repair motherboard, and before sending it to me, he has tried a lot to find the problem. What he has done here, this is the green clock, UG clock, that is the U number, G for green clock. As you know, this is the green clock, and it is not installed on the board. So let's go back and see the RTC area. Just we are checking board with physical damage, whether any physical damage or somebody has worked on it, is it proper or not. This is what we are just trying to confirm. So this is the crystal YC1, okay. So when we talk about the load matter, so most of the time we have seen that RTC area got fail in these types of models. So load is very low. I am going to insert the power supply into the board, and now we will find RTC reset and SRTC reset. What is condition? Now 1 volt per division, as you can see here, and this is the area where we have to check. Now let's come 3.3 volt, that might be RTC reset and SRTC reset. So JME1, we need to open the diagram and write here JME1, and JME1 SRTC reset, and JCMOS1 is the RTC reset. This is the primary reset, this is the secondary reset. Now we have found that both are okay. Now we have to shift it on X10 so that we can check crystal. Now let's come back to the crystal area. and 32 kilohertz must be available. So now here we are going to uh, set it on the auto so that we can see the signal of sinusoidal wave, and you can find here, let me press if there is a measure button, or let me check outside. Somehow it is not looking good, sinusoidal wave. There is no waveform on the outside, or might be somewhere issue on the crystal or capacitor or resistor. So here we are not finding waveform. Let's check it on the crystal. Okay, and let's press auto again. Where is my ground? Come back. Now it is available now. It is written on my DSO. You would not be able to see 32 kilohertz this side. Let me change the reference ground. Now you can see 32 kilohertz sinusoidal wave we are getting, and this side also we have. So RTC area is good to some extent, because not fully I have checked, but primary RTC and secondary RTC we have checked, and 32 kilohertz we have confirmed, and we can say that RTC area has no problem. However, there are the lots of requirement still remaining, which you, if you want to know about all the process of communication, like what are the requirements of the RTC, what is the inputs and outputs of the RTC, then you can join our class, video class, and you can contact on the given number. So they are the basic points which you should always check. Now, what is left? 3.3 and 5 volt. Before that, we have to check what is the scenario of the DCIN voltage. So let's come back to the DCIN area, and here is the first MOSFET and second MOSFET. So both are N channel, and biasing voltage I need to check only, and so that we can confirm that it is switching properly. Now, so here is my gate. So 26 volt. So it is absolutely okay. And the second one, gate 26 volts. So the common area, we are going to check common area. So this is also good. 20.4 volt. What voltage I am injecting? 20.4 volt. Okay. So here on the first MOSFET drain side, I am checking from where the voltage is coming through the DC jack. This is what you have to check always on the DC in area, that the voltage which is available on the first MOSFET drain side, if that is the P N channel, if that is the P channel on the source, must be the same voltage as you have injected the DC jack voltage, and the same voltage you need to get on the common area, common point or sensing register, the same voltage you will meet. So now DC in area is absolutely fine. Light is available, DC jack, so we can say the LDO is not short at least. So let's come here and check this area. This is the 3.3. Also somebody has worked on this. What he has done here? Nothing. Okay. So 8A IC number is here. Okay. 8A is the IC number, and this is the RT8243, and which number you need to remember, that 30 14 and 15 number is always LDO. So here is the 5, 10, 11, 12, 13, 14. 14 is LDO. You have to beware to check it. 5 volt LDO and 15 is a 3 volt LDO. Okay. So that is how you can always confirm 8A is equal to IC, that the 2 number and 4 number is trip, and after turning on you will get trip enable voltage here. Okay, so now let's turn on. Trip will be enabled. Now you can see trip is having voltage after turning on. If it is not turned on that time, that would be grounded. So 4 number is the trip. Okay, and the 100 kilo ohm resistor is installed in order to achieve this 1 volt. That is the logic of the trip. So that is why I'm telling you this is quite impossible to describe all the things which is in containing in our video. Like there are the around 8 to 10 hours the internal logic video of only 3.3 and 5 volt regulator. So that is hardly impossible to describe you on the YouTube. So if you are interested, the number is given. It is up to you. You can leave message on us. So trips are okay. So we can expect that we will be getting 3.3 and 5 volt on the coil. Let's come here and check this point. So these are the coils. Okay. So PL8, PL8, and this is what PL9. These two are dedicated for 3.3 and 5 volt. So now let's confirm first PL9. So this is the PL9. Okay. And let me turn on, because this is the suspended voltage, and after turning on we will get 51 on logic enabled. Then we will get voltage on the coil. So let me insert the DC in. Let me turn on. So this is my true RMS multimeter. So on the outside we need to check. Here we are getting 3.3 volt, or the best option, if you have a true RMS or multimeter, then you should check it on the capacitor area. Okay, so here let's check on the capacitor. So here we are not getting voltage. We need to turn on again. It is turning on and getting off. A very mild load it is taking. So 3 volt on the capacitor side we are having, and 5 volt. Let's check the 5 volt also. Okay, it is also available. As we have suggested you in our video course that you should confirm these things with the help of DSO. Why? Because there might be glitch, and most of the time we have found it. So let me adjust it. As of now we are not getting anything because we need to turn on. Okay, so let me turn on, and at this meanwhile we are going to press autos, because I have checked it 32 megahertz to keeping it on the X10 mod. So I have taken back it on the X1 mod, and that is why I need to press auto once again. So let me turn on once again, and you can see here that 2 volt per division. So here is the 2 volt, 4 volt, and around 5 volt we have. So this is the 5 volt we are getting without any glitch, and here what we are getting on this coil, we are getting 3 volt on this particular coil. So here we are getting 3 volt. So you can see here 3 volt we are getting on this point, and what is this? 5. I think the burning point we have seen here. So register is burnt. I think we are not getting RAM voltage. So let's check RAM voltage. However, it is quite visible here that a register is burnt. So let's find what is that. First of all, let's confirm the RAM voltage. Do we get RAM voltage or not? So let me turn it once again. No variation even. Okay, there is no variation even on this point. So let's open PU3 on the diagram. PU3. So this is the PU3. This is the RAM IC, and let me describe you a little bit here because lots of things are required in order to repair a motherboard, but few things are required here. That system on is required in order to achieve VDDQ voltage. Okay, VDDQ. If you have system on enable, if you have system on the PU3, then only we can have VDDQ on the RAM IC, and then after SLP S3 will come out from the IO, and then we will get the VTT voltage enable. Then your CPU will start communicating or executing codes. Okay, so these two are very essential in order to work the RAM data swapping between the CPU and RAM module. So these two voltage we need to check. So let's come to the PU3. This is the PU3, and here is the requirement enable, VDDQ enable 8 number. We have to check, do we get 8 volt? But before this, what we need to check, always you have to repair like this way. First of all, the supply, all required supply, along with the required current you have to check. Okay, why current is required? Because the IC will not work only with the voltage, because it is, as it is written, the 5.1 ohm is required. So you can calculate the 5 volt will go across this 5 ohm resistor along with some amount of I. So this current will allow to release some frequency with the help of the upper gate and the lower gate. So this IC will start working only when it has the proper voltage as well as proper current. So that is why you have to be cautious. You have to check two things: voltage you have to check, and then you have to check resistor value. If you couldn't check current, then you have to check then ohms. According to Ohm's law, if the V is okay and R is okay, 100% your I is okay. Is that all right? Now, so VDD is the pin number 11. Now let's come to check. VDD is pin number 11. So where is the 11 number pin? Here is the 5, 10, and this is 11. And let me power to board turn on. So you have 5 volt. Okay, on the 11 number pin you have 5 volt. And what else is required here? VDDP is also along with the 5 ohm. It is going to on pin number 12. So let's check pin number 12 as well. So pin number 12. Let me turn on. So we have 5 volt. That is absolutely fine. But if the voltages are okay, so what if there is no current? So here the current is not reaching to, because as it is seen, because it is easily appeared on the board that there is a mark, burning mark on the register. But somehow if you are unable to see on the board any physical, and you find that yes, 11 number pin is 5 volt and 12 number is also having 5 volt, then it is okay. So you cannot say like that. you have to check these two resistor also in order to make it sure that voltage as well as current both are okay. Then we can say it is 100% okay. So now let's come and confirm, remove power, confirm the R value. So 11 number has 5 ohm, 5.1 ohm. So here, as you can see, you have to check two resistor value. One might be backside. So this is quite open. 10 ohm, 9 ohm. Around 8 ohm we are getting. So we cannot say that the resistor is bad. Okay. So it does. If 5 instead of 5.1 ohm, you are getting 7 ohm or 8 ohm. So we can say, however, the 5% tolerance is there. So we can say that it is 100% okay. But why it is burned? Because the high current value has passed out across this resistor and could cause to damage this, IC, the RAM IC. So one more thing I would like to confirm here, that one more resistor of 5.1 ohm must be located for the pin number 12. Now let's go back and try to find here. Yes, here it is. Okay, as you can see here, the 5R1. So this is absolutely fine. So on the ground of these things, that we can say that resistor are okay due to high current passed, that resistor is blown, and we need to check the IC. But before that, we have to confirm that is there any enable is present or not. Now let's come and find out. So here is the IC, and we need to find the enable section. So pin number 5 we have to check. Okay. No other voltages are required. As you can see, these are the VDD-Q. After releasing the VDD-Q supply, when S5 area will get voltage, or it will get enable high logic signal, then you will get 1.35 volt, and then it will come on this area to generate VDD voltage. Okay, this is the feedback, and VDD-Q supply is required in order to generate the VDD LDO voltage. Okay, so on the 20 number you will get VDD supply. So pin number 8 we need to check after turning on, that do we get enable supply on the pin number 8. Now let's come and find. So we need to inject DC into the board, and let me hold multimeter like that. So here is the 5, 6, 7, 8. So 8 number, and now let me turn on. It is on the continuity mode. Now let me set it on the voltage. Turn on. No variation, no fluctuation. Okay. So I'm trying again and again that any load, no voltage at all. So first of all, let's confirm that this area impedance, so it is all right. Also I need to check the shorting on the coil. So 210 ohm you are getting on this area. So I hope that little bit the value has increased. So once we will confirm also, however it is not very much. As you can see that it is going maximum to 6.18, however it is 5 ohm resistor, so 1 ohm has increased. But I think IC is damaged, so let's replace the IC. So I have the same motherboard, donor motherboard, so we will take help of that. So 4B is equal to 2B. This is the IC number. And I have the same donor board. Okay. And let me pick the IC from the donor board. But I think why SLP S4 was not coming, because SLP S4 is the responsible to generate system on, and then your VDDQ will be enabled. So in this model, I have found that if the IC is not good, then why it is trying to stop system on? So let's have a look after replacing that, if any changes we find. There might be two area. There are the two chances to damage. That one is the IC, which we are going to replace, and the second one is the CPU, because after generating VDDQ, it goes to the CPU area. So let's hope for the best. If CPU is safe, then it's good. We will successfully repair. Otherwise, we will give estimate to change the CPU. So now it is done. Let me clean it. So 4B is equal to 3B. I am not going to change this register because the value is absolutely fine. However, it looks like very bad. Okay. 6 to 7 ohm. So it's all right. Now let's check condition. What I was not getting, that was system on pin number 8. So 5, 6, 7, 8. This was the 8 number. Anywhere you can keep it. So this was the 8 number pin. Okay. Now I'm going to power to the board. Now I'm going to turn on. Still the condition is same. Okay. Condition is still same. So what we need to do now? So basic communication, we need to check why system on is not coming, and then the same thing has come back, the communication. So first of all, let me confirm the communication area, and then I will tell you what was the root cause to stop the system on. So guys, I hope that you have seen that all the scenario. Now you have to comment here that what should be checked next, because if you have gone through our video sessions, there we have discussed a lots of things, that how many communications process are required. So what the thing we have left here, in order to these sequence, that RTC we have checked, and the requirement, the system on will come, and then the VDDQ will be generated. So must comment on the comment box that what should be checked now. So keep on liking, keep on loving, and keep on commenting on the video. So thank you guys. See you in the next week.